first two. I'm going to yes. With these first two, I'm going to kind of show you why they work the way they work instead of going straight into telling you how to decide whether to use and or, and then we'll go back and look at them again. Okay, so the first one says the absolute value of x is less than 9, right? So that means the absolute value is going to be anywhere between 9 and absolute value is the distance to 0. So an absolute value that's less than 9 is going to be all the numbers that are between 9 and 0, right? So again, just kind of talking you through how this works. We just said that in order for my absolute value to be less than 9, it would have to be starting at 9, and it's an open circle because there's not an equal to sign there, and it goes to 0, yes? 1, 2, 3, 4, 5, 6, 7, 8, they all have an absolute value that's less than 9. Is that all of the numbers that have an absolute value less than 9? No, because remember yesterday we talked about every number and its opposite have the same absolute value. So we also have to take into consideration the numbers between 0 and negative 9. And where would the numbers be that have an absolute value that's less than negative 9? Would they be to the left of negative 9 or to the right? To the right, so open. And then everything in between negative 9 and 0 also has an absolute value that is less. Does that make sense? Okay. The numbers in between 9 and 0 have an absolute value less than 9. But also the numbers in between negative 9 and 0 have an absolute value of less than 9. What kind of graph is this, and or? When it's shaded in the middle, that's the normal and graph. Mm-hmm. What was my inequality in my original question? It says the absolute value is less than. And we'll come back to writing the interval in just a second. Okay, we're going to come back to that. I'm just trying to show you why and how they work the way they work. The second one is saying that my absolute value has to be greater than or equal to 2. So where are numbers who have an absolute value that is greater than or equal to 2? Are they to the left of 2 in between 2 and 0 or to the right of 2? Okay. To the right? Like 3, 4, 5, they have an absolute value that's great. So it would be closed and it would shade to the right. But that's only half of my answer, right? What other number do we have to take into consideration? Negative 2. And if my absolute value is going to be greater than 2, which numbers are having an absolute value greater than 2 in between negative 2 and 0 or to the left of negative 2? To the left. I was waving at you. I said I was telling you to come in. What kind of graph is this? And what was my original inequality? The symbol, greater than or less than? Greater than. Does that make a little bit of sense on why we shade where we're shading right now? Okay. So I have this little acronym for you to use to help you remember to decide which joining word to use. Once you get your absolute value by itself, then you're going to look at your inequality. And we're going to use this little word right here. You can call it GOLA, you can call it GOLA. I usually call it GOLA, just because it's easier that way. GOLA is going to help me determine which word to use, if I'm going to use and or if I'm going to use or. The G, which inequality starts with a G? Greater than. So if it is greater than, what joining word did I use? Or. And then if it is less than, we use and. Okay, if it is greater than, we use or. If it's less than, we use and. Go LA is what I use for my absolute value inequalities. Now, we already have the graphs for these, but let's talk about how I would do it following my steps, because not all of them are going to be as easy to think through as these two were. Is everybody ready? All right, what's the first step say? I have to get my absolute value by itself. Is my absolute value by itself on one side of that inequality? Yes. Okay. And then I have to decide my joining word. What is that, greater than or less than? Less than, which means I'm going to use and. And then to set up our two inequalities, the very first one is going to be exactly the same, just drop the absolute value bars. So it's going to be x is less than 9. That represents this section right here. For my second inequality, we are going to have to flip to include these. So what we do is we keep the x the same, but instead of less than, it's going to turn to greater than, and instead of positive 9, it's going to be negative 9. You flip both the inequality and the sign. Does that make a little bit of sense? All right, now I would solve each one of these, but these don't really need to be solved. So now the fourth step is to go to my graph. Again, we already have it here, so we're just kind of repeating the process. And just like we did with our compound inequalities, go through each one. X is less than 9 is open and going to the left. X is greater than negative 9 is open and going to the right. And then for and, we shade where they are both true. Are they both true to the far left? No. Are they both true in the middle? Yes. Are they both true to the far right? No. And so once we have our shaded area, then we go and we write our answer in interval notation. Where do I start shading? At what number? Parenthesis or bracket? Okay. All the way to 9 and then parenthesis or bracket. And so that's what my final answer is going to be. Again, on the test, you'll have a place for your graph and a place for your interval notation. Make a little bit of sense? All right, so the next one, again, we already have the graph on the board, but we're going to talk through this. First step is my absolute value all by itself. Yes. Okay, then I need to decide what word. If it's greater than, I use or. If it's less than, I use and. Which one is that one? Or. Okay, so greater than is or. We're going to set up our two inequalities. Just remember, on that second inequality, you not only change the sign of the number, but you flip the inequality around, so it's going to become less than or equal to negative 2. Nothing to solve for here, so I can go straight to my number line. If I am greater than or equal to 2, that is closed and going to the right. If I am less than or equal to negative 2, that is closed and going to the left. The word is or. So one or the other or both. Can I shade to the far left of negative 2? Yes. Can I shade in the middle? Can I shade to the far right of positive 2? Yes. And then from there, that's our graphed answer. We now need to write our interval. Where would I start? Negative infinity to negative 2, bracket. And then don't forget your little union, because we've got two separate interval areas. And then I pick back up with 2, and that's a bracket because it's closed all the way to infinity. Again, make sure the absolute value is all alone. Once it is, you decide your joining word and your or based off of your greater than or less than. Write your two inequalities, and then it turns into the problems that we did on Monday and Tuesday. Does that make a little bit of sense with everybody? All right. Let's try 3. Write it down. We'll work through this one together, just using our steps, and then I'll let you try it. All right, first question, is my absolute value by itself? When I'm asking if the absolute value is by itself, I mean, is there anything on the outside of the absolute value bars? Okay. So is it by itself? Yes. There's other stuff inside, but the inside doesn't matter. It's what's on the outside of the absolute value. So it is by itself. Then I need to decide, am I going to use and or? What symbol is that? That's less than, so we're going to use and. And then I set up my two inequalities. The first one does not change other than leaving off the absolute value bars. The second one, the 2x stays the same. And that is greater than what kind of 3? Negative 3. Right, again, on that second inequality, we flip the inequality and we change the sign. Then we can solve each one for x before we go to our graph. You can leave them as fractions or you can change them to decimals, whichever one you prefer. How do I solve each one of those for x? Divide by 2. So x is going to be less than 3/2, or if you prefer, 1.5. And x is greater than negative 3/2, or negative 1.5. So go ahead and go to your graph, set it up, draw your lines, and then determine where you can shade. The word is and, so we can only shade where they are both true at the same time. If I am less than a positive 3/2, that is open and going to the left. I am greater than negative 3/2, that is open and going to the right. Again, I can only shade where they are both true. Where is that? In the middle. And then I just write my interval. It's going to be a parenthesis, negative 3/2 to positive 3/2, or again, if you're using 1.5, that is fine too. And that would be my solution area. Does that make a little bit of sense? A little bit? All right, try for all the way. I want to point something out. I am seeing the same thing happening over and over again. Is my 5, is that minus 5 inside my absolute value bars or outside? Inside. We cannot move that first. It is held together with the x inside the absolute value bars. So follow your steps. Is my absolute value by itself? Yes. Okay, so that 5 is included in the absolute value. We do not want to get rid of it first. Then we decide what word. Is it greater than or less than? Greater than, which means 4. Then we set up our 2 inequalities. Okay, so I keep seeing people adding 5 first. That 5 is inside with the x, so we have to keep that when we set up our 2 inequalities. Is less than or equal to negative 12, okay? If that 5 had been on the outside of the absolute, then yes, you would move it first. But because it's on the inside, we don't move it until after we set up our 2 inequalities. Does that make a little bit of sense? All right, then we can solve. I get x is greater than or equal to 17, or negative 12 plus 5 is what kind of 7? Negative. So negative 7 is smaller. I am greater than or equal to 17, which is closed and going to the right. I am less than or equal to negative 7, which is closed and going to the left. The word is or, which means I only have to have one of them true. Can I shade to the far left here? Yes. Can I shade in the middle? No. Can I shade to the far right? Yes. And then to write what I have shaded, we're going to start with negative infinity to, with a bracket. Don't forget your union, and then bracket 17 to infinity. Is everybody okay there? All right. Again, be careful. Don't move that 5 first. You have to set up your 2 inequalities because that 5 is inside the absolute values. I would like for you to try both of these. Just be careful with 6. All right, with number 5, it's my absolute value all by itself. Yes, there's nothing on the outside of it, right? Am I going to use and or? And we're going to go x plus 2 is less than or equal to 4, and x plus 2 is greater than or equal to negative 4. We can solve each one of these. I get x is less than or equal to 2, and whoops, x is greater than or equal to negative 6. Negative 6 is on the left, 2 is on the right, and I'm working through this one quickly because everybody had this one right. If I am less than or equal to 2, that is closed and going to the left. Greater than or equal to negative 6 is closed and going to the right, and we shade where? In the middle. And then the interval is what everybody has on their paper. Maybe bracket negative 6 comma 2 bracket. Right, I saw that on everybody's paper. Okay. All right, number 6 is my absolute value all by itself. Yes. Am I going to use and or? And when I set up this second one, it's going to be x minus 1 is greater than what kind of 3? Positive, because it was negative at first. You have to change it to the opposite. I'm going to talk about something in just a second, though. Setting up that number line, negative 2 is smaller than 4. If I am less than negative 2, that is open and going to the left. If I am greater than 4, that is open and going to the right. But we said we have to use and. Where are they both? Nowhere. So what do we put? No solution. I want to ask you something. Look back at your original question. It says the absolute value of some number x minus 1 is going to be less than a negative. What kind of numbers are less than a negative? Negatives, right? What did we say absolute values can never be? Negative. So did anybody recognize that from the get-go without actually solving it? If I can't equal a negative, I can't be less than a negative, can I? If you see that and recognize it from the beginning, go no solution. Also, make sure we talked about this the other day. If you are doing any kind of graphing and it says no solution, just go back and erase and make sure there's nothing closed in or shaded in on that graph. I got one more. Yes, you will get a fraction for one of these. You can change it to a decimal if it helps you.
What was the last thing?
No solution. Because they're not anywhere in the see that negative 1 and think, oh, that must be no solution. You got to pay attention. I think some of us in solving are forgetting when we're dealing with inequalities, what kind of 3 are we going to have to divide by when we're solving it? A negative, and when you divide by negatives, what do you have to do with those inequalities? So be careful with that. Yeah, that's good. Is my inequality by itself? Yes. Greater than or less than? Greater than, which means 4. It's going to turn into less than on the other one, and not -1 but +1. Okay, so first is to be careful solving these. We subtract 4 first, which everybody did. But what kind of 3 is in front of that x? Negative. And when we're solving with inequalities, anytime we divide both sides by a negative, we have to take and flip that around. So that becomes x is less than or equal to a +5/3 or 1.6 repeating or 1.7, however you rounded it. Or the same process here. We've got to subtract our 4 first. That still leaves me with that -3x is less than or equal to -3. Again, I'm dividing by a negative, so that's going to have me flip that inequality around, and that becomes x is greater than or equal to +1, right? What's smaller, 5/3 or 1? 1. Okay, 5/3 is bigger than 1. If you're not sure, change it to a decimal. If I am less than or equal to 5/3, that is going to be closed and going to the left. If I am greater than or equal to +1, maybe, that is closed and going to the right. The word is or, so that means I only need one of them to be true. Can I shade on the left side? Can I shade in the middle? Can I shade on the right side? And my circles are already closed, which means that whole line has been shaded, so this would be, yep, all real numbers, -infinity to +infinity. Look back at your question. It said the absolute value is greater than a negative. Well, if absolute value has to be positive, won't it always be greater than a negative? The little equal to doesn't matter, okay? The greater than matters. Absolute value is always greater than a negative, so that one I could have possibly recognized from the beginning too. Anybody have any questions? All right.